There we go. So I graphed my vector in standard form, and it puts it in quadrant 4. That's important when we're finding theta so that we know it's a quadrant 4 angle. Usually with vectors, we use degrees just because vectors are generally used in navigation, and navigation is generally done in degrees, not in radians. But look at what this question is asking for. It's asking for radians just to make sure we don't forget anything. I just realized I forgot to create that daily quiz for you. I guess I haven't figured out exactly how I want to do it yet. I gotta work on that. Somebody remind me. Who wants to be in charge of reminding me to create your daily quadrant quiz? Okay, somebody be in charge of that. All right, let's go ahead and find our magnitude for this vector. So magnitude v is the square root of 3 squared plus negative 3 square root 3 squared. So that gives us 9 plus 9 times 3, so 27, which is the square root of 36. Okay, awesome. Thank you, Lauren. Which is 6. Oh, then Adrian, you know what? When people volunteer someone else, they volunteer themselves. So, Adrian, you're the volunteer. Okay, so there's the magnitude. You get to decide. And then cosine, not right now though, because I'm busy. So then, what are we doing? We're finding the angle. So for the angle, we're going to do the inverse tangent of negative 3 square root 3 over 3, which is basically negative square root of 3, which means it's a negative 60-degree angle. Am I remembering that right? So negative pi thirds. Okay. Remember how with complex numbers, we had to get used to going from negative pi to pi? In which case, this answer would be right. We're back to going from 0 to 2 pi with vectors for some reason, just because they asked us to. It's good to be versatile. So we need to go ahead and change that to exactly, because they want our answer from 0 to 2 pi. Okay, we have our answers. We have the magnitude of v is 6, and we have the angle is 5 pi thirds. So there's the polar coordinates for the terminal side, the terminal point of our vector. All right, last question. For vectors v and w, find the following. So we're just going to do some arithmetic with vectors here. This shouldn't be too hard. So magnitude of vector v minus 2 times the magnitude of vector w. So let's go ahead and find the magnitude of v by doing 3 squared plus 4 squared. That's easy, it's 5. And then the magnitude of vector w is the square root of 1 squared plus negative 2 squared, which is 4, which is the square root of 5. I found a typo in the textbook last night I need to email Ruth about. Okay, so I'll tell you what the typo is in case you're looking at the textbook. So this gives us 5 for magnitude v minus 2 times magnitude w. So 5 minus 2 square root of 5. The textbook actually says square root 2. So we know that can't be right because I know I did this correctly, don't you think? So then this one also is magnitudes, but this time the magnitude is not around v and around w, it's around a vector that we get when we do that first. So we actually have to take vector v minus 2 times vector w, and that gives us negative 2 comma positive 4, and we're going to combine that with our 3, 4. I think we already did these earlier. This sounds familiar. So 3 minus 2 is 1. Oh, no, this one's different, isn't it? And then that would be 8. Nope, we've not done this one. I thought it felt familiar, but it wasn't. So now we're going to do the magnitude of that vector. So to do the magnitude, we do the square root of 1 squared plus 8 squared. And we get 1 plus 64, which is the square root of 65, and we're not going to simplify that. So that's the answer to that one. So these are just using all these notations we've been learning and the properties we've been learning to go ahead and do some computations with vectors. Flashback